Alright, so welcome back. Today we're taking a look at 3.4, solving our rational functions. So to solve a rational function, we're really looking to do the following steps. If possible, we want to factor all our denominators as far as possible. Because we want to make sure we have common denominators, because we need to get a common denominator as we work through this, and if we don't factor, it'll be tougher to see what things already have in common. We might multiply by something they already have, so we factor everything as far as possible. We do want to also determine the excluded values, the solutions to the denominators. Because if we say, for example, x can equal 4, and we eventually solve and get x equal 4, well, then that's not possible. Once we have everything factored, once we determine our excluded values, we're multiplying all the fractions by that least common denominator to make sure we just clear out our denominators and solve the resulting polynomial equation. But we do need to check all of our answers versus the excluded values, because anything that is the same as the excluded is extraneous, is not part of the final answer. So I've got a couple different examples to illustrate this scenario right here. So for this one, there's no factoring really necessary. They're just monomial terms. We need to get all of them to match up. So we're recognizing that I need to get them all to be an 8n squared. So the fraction here on the right, just got to multiply everything by the 8s. Fraction in the middle, got to multiply by n. And then fraction in the beginning, got to multiply by a 2. So this would become 6 over 8n squared plus n over 8n squared equals 32 over 8n squared. We can recognize, since it's a monomial expression, our excluded value n cannot equal 0. And as for solving, well, once all the denominators are the same, we ignore them and just work on the numerator. So 6 plus n equals 32. Gives us n to be 26, which obviously does not match the excluded value, and therefore that is our legitimate answer. And that's really the process we're going to be going through for the next couple of examples, varying levels of difficulty as we're doing those examples, but that's the general concept of what we're doing going forward. So for this expression right here, we do see we need to actually factor the expressions. Well, we're only really factoring the 1 down here. This is 5 times p plus 6. So we can recognize that we have a p plus 6 expression on both the middle and the right. So the left needs that. So p plus 6 to the left side there. We have a 5 for the left and the middle, so we need a 5 here for the right expression. So we get 7 times p plus 6 equals 1 plus 5 times 2p minus 20, and we know that p cannot equal negative 6, the solution of the factor p plus 6. The 5 does not have a variable, so it doesn't matter. It's only the variable expressions we'd have to worry about. Like if that was 5p, then I'd have to say it also can't be 0. Alright, so we just distribute and solve, so we get 7p plus 42 equals 1 plus 10p minus 100. We're again looking to combine like terms, so this becomes 10p minus 99. If I add the 99 over, I get 141. If I subtract the 7 over, I get a 3. And then when I divide the 141 by 3, it goes into it perfectly, and I get 47. Which again, does not match the excluded value, so we know it's good to go. Alright, so those were our two scenarios where we had to factor. For this last one, the other one we didn't have to factor, but they both create a linear equation to solve. We also can create quadratic expressions, as you're going to see when we work with this one in example number 4. So here we're looking at our denominators. We can recognize that 6b squared is going to be that least common denominator. So I'm going to multiply this middle fraction by a 3b squared to top and bottom. And I have to multiply the right fraction by a 6b. And that first fraction, I don't need to do anything to it. And again, monomials tell us b can't equal 0 then. And now we can just worry about the numerators to solve. We get 1 equals 27b squared minus 6b. So it's a quadratic, so it has to equal 0 to factor and solve. So we get 27b squared minus 6b minus 1. So we're looking to factor this thing. And again, if you need to review how to factor quadratic trinomials, go back to the 2.1 video to go through that. I'm not going to explore that right here. But we do know that we're going to get a 9b plus 1 and a 3b minus 1 when you go through your AC method or your guessing and checking to solve that. The 9b plus 1 will give us b to be negative 1/9, and 3b minus 1 gives us 1/3, neither of which is the excluded value 0, so they're both our solutions. All right, so far we haven't had anything matching the excluded values yet, and that's typical. Most equations you're not going to find something extraneous. You always need to account for it, though, so you need to always be looking at what is my excluded value, what are my actual solutions, because it is possible, just that more often than not, you're really not going to find that on the average question. All right, and then when it comes to like the factoring, typically they'll already have stuff in common, so you can kind of cheat a little bit and recognize if I have the expressions x plus 2 and x plus 3, that's probably how x squared plus 5x plus 6 factors, and that is how it factors. So we can notice that we need x plus 2 on the right-hand side, so that multiplies by x plus 2. We'll know we need an x plus 3 for that left fraction, so we multiply by the x plus 3. And we can see that our excluded values would both be a negative 2 and a negative 3. So now looking at just our numerators, we're dealing with x times x plus 3 plus 2 equals 5 times x plus 2. So this gives us x squared plus 3x plus 2 equals 5x plus 10. So we subtract the 5x over, we get a negative 2x. Subtract 10, we get a negative 8. So x squared minus 2x minus 8 is going to factor and solve. We're going to get x minus 4 and x plus 2, which means we get 4 and negative 2 for our solutions, but we should recognize right there, we said x could not equal negative 2, and now we're saying it is equal to negative 2. So that's our excluded value. That's what it looks like to get an excluded value. So our only proper answer is the x equals 4. All right, so that's the idea we're using to solve out our rational equations. Common denominators either from monomials or factorable expressions, getting linears or quadratics when you solve them out. But always make sure you compare your final answers to the excluded values on the off chance something is extraneous. All right, so we got a couple more videos still left here in Unit 3. We got to take a look at the warp problem scenarios with this stuff, and then we also have to take a look at graphing these rational functions. So I'll see you next time for both those videos.